Huawei Precision Air Conditioner Introduction. Application scenarios of precision air conditioners. This section will introduce the application scenarios of precision air conditioners. The precision air conditioner can be used in a modular data center, FM 2000, and it can also be used in a container data center, FM 1000. It can also be used in medium-sized data centers. This is a medium-large data center. We can see an outdoor unit and an indoor unit. We use a copper pipe to connect the indoor unit and the outdoor unit. The copper pipe has a cold supply aisle and a hot supply aisle. You can see that the air comes from under the floor. This is a large data center. The left equipment room is providing the underfloor air supply. The right equipment room is providing the horizontal air supply. According to their refrigeration structure, precision air conditioners can be divided into the following categories: in-room, in-row, and in-cabinet. What does this mean? Firstly, an in-room air conditioner works for the whole data center room. The air conditioner is installed on one side of the room, and the cold air flows from the underfloor to the cold aisle. This lowers the whole room's temperature. The in-row air conditioner is used for one row of IT cabinets. The air conditioner is installed between IT cabinets. The cold air flows from the front of the cabinet to the cold aisle, cooling the temperature of the cold aisle. Then goes through the IT cabinet to the hot aisle. The in-cabinet air conditioner is an air conditioner which is integrated with the cabinet. It's installed in a cabinet and used to cool down the temperature in that same cabinet. Why do we need in-row and in-cabinet air conditioners? IT power density has increased massively. In-room air conditioners are sometimes too far from the IT cabinets and can't meet their cooling requirements. In-row air conditioners are much closer to the IT cabinets, so they can cool down the air more efficiently. We can use in-room air conditioners in areas with a low IT power density, and use in-row air conditioners and in-cabinet air conditioners in areas with a high IT power density. Of course, in one data center, we can use several different solutions, as this picture shows. Air conditioners can also be classified according to their method of cooling. In this way, air conditioners are divided into two categories: air-cooled and chilled water. An air-cooled precision air conditioner consists of an indoor unit and an outdoor unit. A copper pipe connects the indoor and outdoor units. The system also includes a refrigerant chemical. The outdoor unit is a condenser. The indoor unit includes a compressor, expansion valve, and a evaporator. In the chilled water air conditioner, we can see that there is a chiller on top of its roof, which generates chilled water. When the chiller generates chilled water, a pump then supplies chilled water to the indoor unit. In addition, the indoor unit can also absorb heat from the data center room. Now let's see the application of the different air conditioners. In this graph, the horizontal axis shows the power of one cabinet, and the vertical axis shows the total IT power. The horizontal axis shows that if the IT power density is smaller than 5 kilowatt per rack, we would typically choose the in-room air conditioner. The vertical axis shows that if the total IT power is greater than 1,000 kilowatts, we should choose the chilled water air conditioner. If the total IT power is smaller than 1,000 kilowatts, we would normally use an air-cooled air conditioner. As the chilled water solution has a better cooling efficiency, it's suitable for large-scale data centers. In summary, we can see that if the power density and total IT power are both large, we should choose the in-row chilled water air conditioner. However, if the power density and total IT power are both small, then we should choose the in-room air-cooled air conditioner. That's all for this section. Thanks for watching.